66 million years ago, the Earth was at its absolute peak. No ice caps at the poles. Vast green forests covering everything. Shallow inland seas gleaming in the sun. The most spectacular age of large life this planet has ever produced. And in space, a dark rot, 10 kilometers wide, moving at 70,000 kilometers per hour. Its trajectory locked onto Earth. The last morning of the dinosaurs began like every other morning. A Tyrannosaurus rex, 2 tons of muscle and instinct, moving through the late Cretaceous forest with the unhurried confidence of an animal that has no predators. Then stopping, raising its massive head, looking at the sky. Something had changed, a brightness appearing, brighter than the sun. The asteroid was entering the atmosphere. A rock 10 kilometers wide, its leading edge glowing white-hot from the compression of air, brighter than the sun. Visible from half the planet. Below, the Yucatan Peninsula, the shallow coastal shelf, the limestone and gypsum seafloor, completely unaware. Then the moment of impact, the asteroid hit the shallow coastal sea of what is now Mexico. In the first millisecond, everything within hundreds of kilometers simply ceased to exist. Rock, sea, air, all converted to plasma hotter than the surface of the sun. The energy released was equivalent to 1 billion Hiroshima bombs. In a single moment. You are watching History in the Shadow. Like and subscribe for more. Welcome to History in the Shadow. I am your host, Shoyu. Let us start the story. To understand what was lost, you first need to understand what existed. The Cretaceous Earth had no ice caps at the poles. The continents were in different positions than today. The atmosphere was warmer, more consistent. A greenhouse world, 20 degrees warmer at the poles than the Earth we know, and the life it contained was extraordinary. The Cretaceous forests were dense and alive. Towering conifers mixed with early flowering plants, tree ferns covering the forest floor, cycads in the understory. Dense green growth in every direction. Moving through those forests were the Triceratops, living tanks, each one the size of a large vehicle, 3 horns, a massive bony frill, moving in herds like bison, their powerful beaked mouths cropping ferns and cycads with relentless efficiency. In the river valleys, hadrosaurs crossed in herds of hundreds. Their hollow crests acted as resonating chambers, the sound carrying across valleys, specific dinosaur communication audible to everything within miles. The most numerous large herbivores of the late Cretaceous, their herds keeping the forests from growing unchecked. The ankylosaur moved slowly through the undergrowth, its entire back covered in thick plates of bone, a massive club of solid fused bone at the end of its tail capable of shattering the leg of any predator. The confidence of an animal that nothing could easily penetrate. Above them all, Quetzalcoatlus, a pterosaur with a wingspan of 11 meters, larger than a small aircraft, soaring on thermal air currents above the Cretaceous landscape, capable of traveling thousands of kilometers without effort. The largest flying animal that has ever existed, and at the top of the food chain, Tyrannosaurus rex, 2 tons of specialized predator, a skull 1.5 meters long. Teeth the size of bananas, serrated for cutting through bone, the product of 165 million years of evolutionary refinement. The T-Rex hunted by moving through forest edges, its large body surprisingly quiet. The burst of speed when it came was estimated at 20 kilometers per hour, brief and decisive. Beneath the waves of the Cretaceous seas, mosasaurs, large elongated marine reptiles, hunting ammonites, spiral-shelled cephalopods, some the size of dining tables, thousands of species across the Cretaceous oceans, every one of them domed. Plesiosaurs swept their long, flexible necks through schools of fish, their 4 large paddle-shaped limbs moving in an underwater flying motion. And in the darkness of the forest floor at night, small mammals, roughly the size of rats, large eyes adapted for night vision, moving carefully through the leaf litter, hunting insects and seeds, stopping at every sound. These were the creatures that would inherit the Earth, completely invisible in the shadow of the giants. The asteroid had been forming its approach for billions of years. In the asteroid belt between Mars and Jupiter, among millions of rocky bodies, one particular asteroid, 10 to 15 kilometers wide, composed of dark carbon-rich rock, formed in the outer solar system. The gravitational influences of Jupiter and Mars slowly shifting its orbit over millions of years. The trajectory changing, millimeter by millimeter, across geological time. By the last hours, it was crossing the Moon's orbit in 30 seconds. Earth ahead, the blue and white planet, the Yucatan Peninsula visible at the edge of the Gulf of Mexico. No warning, no sound, no creature on Earth aware. On the last morning in the Hell Creek River system of what is now North Dakota, a warm subtropical environment, forests of palms and flowering trees, ferns along the river banks, dinosaurs were going about their morning. A T-Rex moving through the tree line. Hadrosaurs at the river's edge drinking. Small feathered dinosaurs hunting insects in the undergrowth. Everything normal, everything alive. The last ordinary morning. Then the sky brightened. A hadrosaur at the river's edge lifted its head from drinking. A T-Rex in a forest clearing stopped moving. A Quetzalcoatlus folded its wings. All of them seeing something in the sky, a brightness growing, becoming brighter than the sun in a clear sky. For perhaps 1 second. Then the asteroid hit the upper atmosphere, the air compressing ahead of it, the compression heating that air to plasma, the leading edge glowing white-hot. The atmospheric shock wave running ahead of the rock, hitting surface below before the asteroid itself arrived. And then impact. The Yucatan shallow sea. Warm water, limestone and gypsum seafloor. The kinetic energy converting to heat in a fraction of a second. Everything within hundreds of kilometers, rock, water, air, converted to plasma. The explosion expanding outward at unimaginable speed. The crater formed in minutes. Liquid rock pouring in. Mountains higher than the Alps forming and collapsing within the same minute. 180 kilometers wide. 20 kilometers deep. The largest geological event in 66 million years. The shock wave crossed North America faster than sound. Trees flattened before the sound of the impact even arrived. Entire late Cretaceous forests pushed flat by the expanding pressure wave. The earthquake. A magnitude impossible in normal geological time. Every major fault on every continent triggered simultaneously. The planet resonating with the energy of the impact, ringing like a bell. The Gulf of Mexico displaced. Walls of water, kilometers high at the impact zone, moving outward at the speed of a jet aircraft. Hitting the coast of what is now Texas and Louisiana, driving inland for hundreds of kilometers, carrying everything with it. The ancient forest swept away. The soil stripped. The coastal ecosystems scoured clean. Billions of tons of rock thrown into the upper atmosphere and beyond. Some pieces achieving escape velocity, leaving Earth entirely. Billions of fragments following ballistic trajectories, arcing upward, then falling back. The re-entry beginning. The rocks heating as they contacted the atmosphere again. A global shower of incandescent material. The sky briefly lit by billions of simultaneously re-entering fragments. The temperature of the lower atmosphere rising dramatically. Thousands of kilometers from the impact, the surface temperature exceeding what was needed to ignite vegetation. Forests not burning from spreading fire but igniting from radiant heat. The same mechanism as an oven. The Cretaceous world on fire across vast areas simultaneously. Not from a single source. From everywhere at once. The largest animals, the most exposed, the ones with no ability to burrow or shelter underwater, dying in vast numbers in those first hours. The giants that had ruled for 165 million years, collapsing in hours. But the direct heat was not the real killer. The real killer was what went into the stratosphere. The Yucatan seafloor was rich in limestone and gypsum, calcium sulfate. The impact vaporized billions of tons of these sulfur-containing rocks. The sulfur aerosols driven into the stratosphere, above where weather occurs, spreading around the planet on stratospheric winds, distributing evenly across both hemispheres over days. The sun beginning to be reflected back into space. Day by day, the Cretaceous world darkened. The sky hazy. The light insufficient for normal photosynthesis. Temperatures dropping as the reflected sunlight failed to warm the surface. The impact winter beginning. Destined to last nearly 2 years. Not complete darkness, but insufficient light. The sky a perpetual gray-brown haze. Rivers beginning to freeze at edges. The wan Cretaceous climate gone, and then the plants began to die. The base of every food chain, failing. ferns and cycads, yellowing, flowering plants failing to flower, trees drawing on stored reserves until the reserves ran out, plant after plant dying across the global landscape. The hadrosaur herds moved across landscapes that had changed, the vegetation thin, the once dense growth reduced to struggling survivors, the animals growing weaker, the caloric intake insufficient for creatures of their size, juveniles failing first, the calls that had echoed across the valley, now absent. The Triceratops found no vegetation, moving through a landscape that was once dense with the low growth they cropped, spending more and more energy searching for food, finding less and less. A Triceratops collapsing in what had been a rich feeding ground, not killed by the impact directly, killed by the absence of what the impact took away. T. Rex Day 1, the apex predator, became the most vulnerable, moving through a landscape of dying forests and absent prey, their herbivores gone or dying, the massive body that had been its advantage in the Cretaceous becoming its fatal vulnerability, needing enormous caloric intake to maintain its mass, finding the prey it had specialized in hunting absent. In the oceans, the phytoplankton, the tiny single-celled algae forming the base of nearly all ocean food chains, dying in the darkness. The food chains collapsing level by level, the zooplankton dying, the small fish dying, the larger fish dying, the marine reptiles finding nothing to eat in darkening seas. The ammonites, 300 million years of evolutionary success, failing species by species, their eggs not developing without sufficient warmth and food, the spiral shells sinking to the ocean floor for the last time. But not everything died. Crocodilians in rivers barely moving, their cold-blooded metabolism slowed almost to zero, surviving on stored fat reserves for months without food. The metabolic flexibility that will carry these animals through to become the largest surviving reptiles of the modern world. Sea turtles diving to depths where the impact effects at the surface were less severe, their cold-blooded physiology, their minimal metabolic requirements, surviving what the warm-blooded giants could not, and deep in the earth, the small mammals, curled in burrows, insulated from the surface conditions, their small bodies not requiring enormous caloric intake, eating whatever they could find, insects, seeds, anything organic, the generalist diet of the Cretaceous mammals serving them perfectly in the impact winter, the heartbeat continuing, small and fast through the dark and cold, the future of mammals, of primates, of humans, contained in that small warm body underground. In North Dakota, 66 million years ago, a river system was experiencing something extraordinary. The seismic wave from Chicxulub arrived hours after the impact, disturbing the river. Then a surge, a wave of water driven by the seismic disturbance rushing up the river valley. The fish, paddlefish and sturgeons, buried alive in the sudden flood, the sediment covering them in hours. In their gill filaments, tiny glass spheres, ticktites embedded in tissue, formed when rock was vaporized by the impact and thrown into the atmosphere, re-solidifying into glass droplets as it fell back. These fish were alive and breathing when the first ticktites fell, hours after the impact, before the surge that buried them arrived, the most precise timestamp in the geological record, the last hours of the Cretaceous, recorded in fish gills. In 2019, paleontologist Robert De Palma discovered this site, named Tanis. Not just another fossil deposit, a snapshot of the actual day of the impact. Hundreds of fish preserved in extraordinary detail. The scale of what was lost across the entire planet, 75% of all species, gone. The iridium layer, found everywhere on Earth, a thin clay layer at the KPG boundary containing iridium 30 to 160 times higher than normal. The fingerprint of a vaporized asteroid, distributed globally. In 1977, geologist Walter Alvarez was working at a limestone outcrop in Gubbio, Italy. He measured the clay layer at the boundary. The iridium levels were impossible. He sent samples to his father, Nobel Prize-winning physicist Luis Alvarez, at Berkeley. The numbers matched the pattern of a vaporized asteroid. In 1980, they published the impact hypothesis. The scientific community was skeptical, but the evidence accumulated, year by year. The shot quartz, found worldwide at the KPG boundary. Quartz with parallel deformation lines in its crystal structure that can only be produced by the extreme pressure of an impact. The tiny glass spherules. The global distribution. Then in 1991, geophysicists studying gravity and magnetic anomaly maps of the Gulf of Mexico identified a circular pattern centered on the small town of Puerto Chicxulub in the Yucatan. The Chicxulub crater, 180 kilometers wide, buried under a kilometer of sediment. The final piece of evidence. In 1991, the scientific consensus was complete. 41 scientists reviewed 20 years of evidence and agreed unanimously. The Chicxulub impact caused the KPG extinction. The cenotes of the Yucatan, the sacred water sources of the Maya, follow the arc of the buried crater rim perfectly. The Maya walked the circumference of the greatest geological event of the Cenozoic for thousands of years without knowing it. In 2016, a scientific drilling expedition brought up core samples from inside the crater. Granite, normally 20 kilometers underground, now at the surface, lifted and reset by the impact in minutes. The scientists holding rock that was deep in the Earth's crust 66 million years ago. The recovery began quietly. 2 years after the impact, the aerosol layer began to thin, the sulfur settling out of the stratosphere, more light reaching the surface. The first clear sunrise in 2 years. Ferns were the first to return, their spores tough enough to survive. The growth rapid in difficult conditions, a thin carpet of green covering the devastated surface. Then seeds that had lain dormant through the impact winter, buried in soil, waiting for light. Germinating. The first seedlings pushing through the damaged soil. Flowering plants returning first, their seeds tough and their growth rapid. The small mammals emerging from their burrows into a world that had changed. Beginning to grow larger over millions of years. Evolving specialized teeth. Some growing to sizes that would have been impossible when T-Rex was alive. The birds, the feathered dinosaur lineages that survived, emerging into a recovering world. The only living dinosaurs, eating the seeds of recovering plants. Their small size and generalist diets having served them through the impact winter. And then, 66 million years of mammalian evolution. The small Cretaceous mammal becoming the first large Paleocene mammals. Then the whales, evolving from land mammals that waded into the sea. The horses, evolving from dog-sized forest animals to the open plain runners we know. The elephants, the great apes. The upright walking primates. And eventually, in geological terms barely a moment ago, us. The catastrophe that created the conditions for us. The world today, elephants at a watering hole. Dolphins in the ocean, eagles in the sky, all of it existing because of the impact that cleared the ecological space. The asteroid that ended one world and made another. If the asteroid had missed, the dinosaurs would have had 66 million more years of evolution. The ecological space for large mammals would never have opened. The specific evolutionary path that led to primates, to great apes, to bipedal hominids, closed. No humans. Because the sequence of events that produced us depended entirely on the trajectory of a rock from the asteroid belt. The asteroid belt is still there, between Mars and Jupiter. Millions of rocky bodies in their orbits. Modern astronomical observatories scan the sky systematically, tracking thousands of near-Earth objects, calculating trajectories, determining future paths. In 2022, the NASA DART mission deliberately crashed a spacecraft into the moonlit Dimorphos and measurably changed its orbit. The first time in the history of life on Earth that a species has successfully altered the trajectory of an asteroid. For the first time, life has a way to try to prevent what happened 66 million years ago. The Chicxulub impactor, a C-type asteroid, formed in the outer solar system containing significant iridium, preserved from the formation of the solar system. Its composition readable in the thin clay layer it left behind. The entire catastrophe compressed into a few centimeters of rock. The impact angle was approximately 15 degrees above the horizontal. Modeling shows this shallow angle maximized the ejection of material into the upper atmosphere. A steeper angle would have produced less severe global cooling. The specific angle, another contingency that amplified the catastrophe. 2 degrees different. The world changes. The dinosaurs possibly survive. The mammals remain small. We do not exist. The impact also released sulfur dioxide that reacted with water vapor to form sulfuric acid. Acid rain falling globally for years. The oceans acidifying. Marine organisms with calcium carbonate shells, including ammonite, their shells dissolving in the acidifying water. Nitrogen oxides produced in enormous quantities. The ozone layer being destroyed. Ultraviolet radiation increasing dramatically. Multiple simultaneous attacks on the biosphere. Darkness, cold, acid rain, UV radiation, all operating together. The recovery took millions of years. The devastated Paleocene world gradually filling with life. 1 million years later, the vegetation denser, some larger animals appearing. 5 million years, ecosystems beginning to recover complexity. 10 million years, the Eocene world, mammals, diversifying rapidly. 66 million years, us, looking back. The dinosaurs that survived, the feathered theropod lineages, diversified rapidly in the absence of most competition. The birds of today, every species alive, direct descendants of the Cretaceous survivor. Their feathers descended from the feathers that T. Rex's relatives wore. Their hollow bones descended from the hollow bones that lightened Cretaceous raptors. The dinosaurs are not extinct. They're transformed, miniaturized, feathered, flying. Every bird on Earth today is a living dinosaur. The small Cretaceous mammal whose descendants eventually climbed into trees developed grasping hands and forward-facing eyes. Then the brain grew larger. Then the posture became upright. Then the hands that once gripped branches held tool. Then those hands looked at fossil dinosaur bones, understood what they meant. We are the children of the asteroid. We are the heirs of the small warm-blooded creatures that outlasted the giants. We are the first species in the history of life on Earth that can look at a piece of KPG boundary clay, a few centimeters of rock containing iridium from the vaporized asteroid, shocked quartz from the impact, tictites from the atmosphere, carbon from the global fires, sulfur from the Yucatan seafloor, and understand exactly what it means. That can feel something like gratitude and something like terror simultaneously at the rock that ended one world and made ours possible. 165 million years of dinosaur rule. One day, one rock. The rock did not know what it destroyed. It did not know what it created. Life does not give up. It transforms. The asteroid belt is still there. The rocks are still moving. The physics of orbital mechanics has not changed. What happened 66 million years ago can happen again. The question is not whether it will. The question is whether the first species in Earth's history capable of preventing it will choose to do so. In 2029, an asteroid named Apophis, 300 meters wide, will pass Earth closer than the orbit of our own satellites. Visible to the naked eye. The closest large asteroid approach in recorded history. Not on an impact trajectory, but close enough to see. A reminder written in the sky and in every bird that flies, in every sparrow, every eagle, every penguin, the living connection between the Cretaceous and the present, the descendants of the survivors, carrying the story forward. The Earth has faced catastrophe before. The Permian extinction, 96% of all species gone, the worst mass extinction in Earth's history. Life answered. The Triassic extinction, 80% gone. Life answered. The Cretaceous extinction, 75% gone. Life answered. Each time the biosphere was devastated. Each time the world was transformed. Each time something new emerged from the wreckage. That is the deepest truth of Earth's 4 billion-year history. Life does not give up. It transforms. We are the latest transformation. We are the children of catastrophe, looking back at the bones of the giants, looking up at the sky, and for the first time in the history of life on Earth, watching for what comes next.